All right, welcome everyone. Today we're going to be talking about relational database management systems. And speaking about relational database management systems, the one database management system that we're going to be utilizing today, and pretty much our entire cohort, will be PostgreSQL. Yes, there are others out there that are SQL oriented, but we'll be utilizing PostgreSQL for this cohort. So today we're going to be covering why database management, why databases, what are the challenges of trying to store data or save data without having an actual database management system to keep records of all of our information. And then we'll go over what that would look like utilizing a Python program with CSV files so that we can explore some of the problems and deficiencies of doing it this way. And then finally, we'll go into an actual introduction of PostgreSQL, running PostgreSQL onto our machine, writing CSV files, and creating our very first data table. Does anyone have any questions over anything that will be covered today?
Hand raise.
Go ahead, Lynn.
Sorry. It's not really a question, but last week my system failed and I redid the install fest. And I think that Postgres, I don't think I got to that part. So if we could on a break, like take 5 minutes and I'd appreciate it.
Absolutely. Thank
So
you. All
thank
right.
you.
Awesome. So with that said, let's go into why relational database management systems. So I'm just going to start calling them RDBMSs, or just start calling them databases from this moment forward, so I don't have to say that whole mouthful over and over again. But why do we think databases are important? Right, so far up to this point, especially after assessment one, we've seen how to manipulate data that's being stored inside of a CSV file. And typically, when you're working with some sort of Excel sheet or maybe something in Google Sheets, you'll notice that a lot of that data can be easily downloaded as a CSV file. So what problems do we think we could encounter if we're just manipulating data through a CSV? All right, let's hear it, Eric.
Other computers won't be accessing that same data if you're writing to a local CSV file. Could be a
Okay,
challenge.
awesome. Yeah, so if we have machines, right, multiple machines that require this information in a live style, we can't really do that. We could use something like a version control to consistently push and receive information like GitHub, right? But just like Eric mentioned, that's probably not the most ideal way to do it. And we need a way to interact with this data um, in more efficiently and as needed, right? So that everybody can share the same information as we're programming. So let me present you with this issue, right? Let's say you're running some sort of store, right? You have some sort of hardware store. Your hardware store has inventory. They all have different prices. Um, and let's say you're not really doing your database management through one centralized way. You have every single department has their own set of spreadsheets and they keep their own tabs of how much each individual item is within their own department, right? Now, let's say one department switches their prices just as simple as going up 10 cents. What does that mean as far as data consistency for all other departments, including yourself as the owner? What would need to get updated?
Can you repeat that one more time, please?
Yeah, and maybe this is something that we could actually draw out here. It might be better that way. Let's go ahead and bring that over here. Let's go over to TL draw, and let's take a look at our little department store issue. All right, so here I have a department store. In my department store, I have several other smaller departments. Let's say I have a hardware store. Some of them keep track of tools, some of them keep track of actual amenities, et cetera, right? I have my nuts and bolts. And then I have myself, a copy of each one of these departments, right? Well, one of them raises their prices just 10 cents up. But we all need to have the same information. So what does that mean when one of them changes their prices and have their own copy? What needs to happen to everything else? Go for it, Len.
So if they raise it, there's probably, let's talk about it from the software point of view. You update the and going back to the Blockbuster video, let's just say it was like the price of a video and it was in that CVS file or CSV file, sorry. Update that price block, then you got to also make sure that gets to everybody else. But if everyone's on like an S drive or a shared drive, not a shared drive, or how do you ensure that it gets put in the right folder? There's like a sync problem, really, is what happens, and then versioning control and pure insanity, or how the DoD operates.
Yeah, perfect. I couldn't have said it better myself, right? If one department changes something, well, now all other departments need to be informed about this change, meaning that one change of one specific data type or one data cell needs to be reflected 3 separate times. Not only does it have to be reflected 3 separate times, but it has to be reflected efficiently, meaning quickly and accurately, right? If we take this into a broader spectrum, currently right now we're looking at a hardware store, which you may think, oh, not a big deal, right? We have one single department head. That one department head has a runner. If he makes a change, well, then that runner goes over to the other departments and informs them, right? What if we're looking at a actual business with multiple locations all throughout the country, right? One of them's located on the far east, one of them's located on the far west, and then we have one down south. All right. Well, and let's say we're back into medieval times and we don't have our ability to send a nice handy dandy email. Well, now this traveler or this runner that we just specified has to essentially travel throughout the entire country to deliver this information. And if we think about it in a time perspective, by the time he gets there, there's a good chance that prices might have already been updated again. All right. So we have a serious problem as far as consisting data without actually sharing it in a live server to one another. All right. So now let's take a look at our current solution. So far, what we've thought about when it comes to data and how to handle data is through a CSV file. In this case, I'm going to go ahead and utilize some of the information utilized through provided to us by our curriculum. So I'm going to make a student portal here, and this is going to be the beginning of our project. By the end of this module, we'll have a full stack application with HTML, CSS, JavaScript on the front end, a Flask API, and a PostgreSQL database. So let's start with our database now. So here I'm going to make a students.csv file. And the CSV file is going to hold the current information, right? So whether we can see every student has an ID, they have their first name, their last name, their age, and their grade. Something pretty simple. And so far, the way we've learned how to manage this information is through object-oriented programming. So how could I do that? All right, I want to grab this CSV file, manipulate the data, and keep track of all students existing. Can anybody walk me through creating a class with potentially a couple of class attributes and instance attributes to hold this information? All right, let's hear it, Len.
This is like a public math here, so here we go. So we're making the class, and it's about students, so let's just call the class students.
Okay.
So class space, well, do you have a file? Yeah, thank you. That's good. That's good. Thank you. That works.
All right.
So class students, uppercase with an S, yep. And then parentheses, and then the header. And then do the dunder init. And in there, can we go back to I just want to, is it possible to put both of them up here? Yeah, there we go. Boom, nailed it. So obviously you're going to want the ID. You're gonna want a first name, last name, age, grade. I'm not gonna worry right now about getters and setters or making things private. Let's be on the scope of this project. Let's focus on Postgres. Okay. And then so self dot ID equals ID and so forth and so on for all of the who's in the what's its attributes. Is that the right word? Is that the right word? Attributes.
That's right.
Okay,
We're
thank you.
all of our instance level attributes.
Right. Okay. So then after this, that's going to initialize it, the data that's going to be put in there. You probably want a load. So a def load, well, yeah. Data, and I'm not going to try and publicly do this one because it's, oh, we got to import CVS.
All right, let's do that.
CSV. Man, I took my daughter to CVS yesterday for her meds, and I've been doing it all day. I've been confusing those two things. So just bear with me.
Of course.
And then in that, you're gonna need the self. And then we can just call it file. And then when we go down there, yeah, that's a good idea. And then, I mean, you do want to get the getters and setters. What was the exact question? What are we trying to build here? I want to make sure we're trying to manipulate the data, right?
Yeah, this is a good stopping point right
Okay,
here.
cool.
I think we have the majority of the things that we need up to this point.
Because I think getters, setters, and deleters would be the next thing for just manipulating more and having a little bit of control for private data, possibly. But at that point, I'll shut up.
Right. Yeah, that would definitely be our next step. But to try to keep things simple so that we don't run out of time, currently we have my init method, but it seems like I have a little bit of an error in my init method. Can anybody tell me what I'm missing there?
Yeah, we're missing self in it when we initiate the class student.
Awesome. Yeah, we are missing self. Let's ensure that we're using the hand up system. That way we can have some organization here. All right, so now I have self, I have my IDs, and I have all this information. Now, currently we established that we need a method named load data to be able to grab information, and I'm currently utilizing self. When I utilize self, that's to indicate that this is an instance level method. But if I'm going to create instances from a file, should a student be able to create other students? No, right? So what kind of level should this method live at? Should it live at the class level or the instance level? All right, Murad?
Class method,
Yeah, this should be a class method.
and then we're gonna import the data.
Perfect. Yeah, so we have our class method. I'm going to change this self for CLS. It doesn't actually stand for anything. Remember, this is just a variable, but this is purely so that other developers can see that and say, oh, this is referencing the class, not an instance. All right, so now I have a class level method. We established that we have all of our attributes that are coming from the CSV file that's working well. And we know that we're going to need this class level method. But once we load all of this data, where are all these students going to go?
We need to, sorry,
Go for it, Brandon.
we need to instantiate a dictionary above our class right there, in order to hold a collection of students.
All right, and you mentioned a dictionary. So we'll go for a dictionary data structure here. We could just keep it with a
list.
that would also work.
Yeah,
But I do agree that a dictionary would be better as far as storing data and having direct access to it. All right, so now we have our information. We have our class built out. It's able to accept our students, and we could finally load some data. All right, I'm gonna go ahead and call on somebody to help me build this function at this point. Oh, go ahead, Brandon. Do you have a question?
Nope, I wanted to try my hand at it.
Ah, got it. I'm gonna have you hold here. I want to make sure everybody gets to participate in the class. So, Mikhail, if you could walk me through this process real quick.
Yes, so I think we would use like a data file. So you can assign data to be the distance, the path to the CSV file.
Okay, so I'll rename this instead of file, I'll name it path to CSV file. All right.
Now you can rename that file again.
Okay, awesome. Then I'll just rename it file.
And with the path, you can say with open.
All right, so we're gonna be utilizing the open function to open a CSV file. All right.
And then you can say file and then comma R. And you get no comma, yeah. So you say as CSV. And then you can say reader equals CSV. I think it is dot dict reader. And CSV file. And inside you can say for row in reader. Person or student, yeah. Student equals you could say students and then use the that ARGS thing, the 2 stars in a row, 2 stars in a row. And after that, so you put that in there, and then students, and then you have the open brackets, and then you have student dot ID, and then is equal to student.
All right, we're pretty close here. I believe what we wanted is not the class students, but the attribute students.
Yes.
Let's go ahead and enter our class and then grab the attribute students to then add the student ID and make that equal to student. All right, that's looking great. So let's do a quick summary of what we've done so far. We received a CSV file. From the CSV file, we identified the headers, our ID, first name, last name, age, and grade. In order to be able to interact with this data, we created a class named students that has a class level attribute students, which is where all the instances will be stored in a dictionary fashion, where the ID will be the key and the instance of a student will be the value. We then created a init method that will take in all the appropriate headers, set all of the instance level attributes, moved on to a class method that will load a data depending on the file path, utilize the open function to read the file with CSV dict reader so that we have dictionaries per every row in the reader. And from there, we're going to create a student instance for each one of these students in the CSV file and append them, or excuse me, add them into our dictionary with their appropriate key value pairs. All right, let's open up the floor for some questions at this time. Chris?
Yes, for row 19, I keep forgetting. I know that's a spreader, but for row, what does that do? Or does it just go each row?
Yeah, that's a good question. I see what that does. Let's see. How could I do this? Let me try doing it this way. And then let me try. Oh, that's not it. There you go. That. All right. So currently we have a function, right? So the def init is a function. We have a function that takes in these arguments: ID, first name, last name, age, and grade. Well, inside of my CSV file, currently I have this ID, first name, last name, age, and grade. But once that gets put through the dict reader, it ends up looking as a dictionary that has ID with value. It has first name with value, and so on. All right, I don't want to spend too much time on that part. So what happens when I utilize the star method? So when I try to initiate an instance of the class, all I'm doing is I'm calling this function. All right, this function's being called, and this function knows it needs these parameters. Well, when I pass in star, it's doing the structuring to grab each individual value from the dictionary. So when I do star, I'm telling it, hey, ID should exist somewhere in this dictionary. So look for it. It doesn't matter the order. I could have it last, I could have it first. It is looking for a key named ID. When it goes on to first name, I am telling it, hey, this dictionary here should also have a key named first name. And it does that all throughout the different parameters that this function is looking for. So all I'm saying is for each one of these parameters, find a key that matches the naming convention of the parameter and insert the value. Does that answer your question, Chris?
Yes. Follow up to another question.
Yeah.
So in this, what we're doing, loading the file, we are only looking for the ID or the key. We were just only looking for ID for this file.
No, we're grabbing everything from this file.
Okay. So what is student.id? Is that just because it's first?
Are you talking
yeah,
about?
Yes.
So here what we're doing is we're creating a dictionary up here of
Okay.
students where the ID will be the key. Right? So by
Gotcha.
the end of this, we'll have it. Let me show it to you real quick. That way I can make sure that it's working correctly. So let's do students.load data. And the file is named students.csv. And then after that, let's print students.students. And actually, I'm going to print it before so that you could see it. Empty. And then I'll print it again so that we could see it afterwards. All right. So there we can see an empty dictionary.
Okay.
That comes from our first print students. After that, we load the data. And what this CLS students, where the student ID is being inserted, I am making the key the ID of each individual student. That's why we see 1, 2, 3, 4, and 5. With the student instance being the value.
Gotcha. Which we haven't added yet.
The student instance is the value. I mean, I could add a representation method here. And there you can see an empty dictionary. All the students get loaded, and then we have our dictionary for each individual student.
Wow. Amazing. Thank you. Okay.
All right, Brandon.
Yeah, could we add in a print statement above line 22 that says print and then a quargs row, dictionary row? So dictionary quargs row.
Like that.
Well, there needs to be a dictionary wrapped around it, I believe. And so this should show us what we would write out in the represent method. Yeah, so it's basically doing that without the class itself. So it's printing the row. And if we look at the right hand side, we can see that everything matches, right? So it's ID of 1 and then John Doe 18A. That helped me out a lot personally. So, you know, just
All right, awesome. All right, everyone. So now that we know where we're currently located and the work that we've done so far, we know that we can load all of this information, right? But now let's say that we wanted to do something just like updating a student name, or, you know, what if we wanted to have the ability to add a student or delete a student? A couple of other different things, such as writing some values. So let's keep it to adding a student, and then we'll go over writing this information, right? So how could I create a method that would add a student? Can anybody help me out there? All right, this is concerning if nobody can help me out with how to create a class instance or create a method for that. So I'm gonna ask again, can anybody help me out? All right. Oh.
You would, oh,
Go
sorry.
ahead, Erica.
Or you would have to add a class method, define the function as add a student, put the in between class method and then let's say student the variable, and then I mean, it depends on the variables you want to put in, but you would have to put class dot student the dictionary input, as a class dot, let's say you're adding it by ID equals the student.
Okay, give me a second here. So
Sorry.
I got you up to, you're saying you're gonna take in a student. Is it
Yes.
student instance or a student dictionary?
That would be, oh, I'm making it an instance and adding it to the dictionary. That would be, so that would be cls dot student. I forget what yes, that I forget what the sentence called. And then students, you're adding it by ID. Did we establish it was ID? Yes, equals student.
Okay,
And then I'm guessing you want to return a statement that if it was added.
yeah, so let's return an F string saying student dot first name has been added to. All right, so this works as a method for just adding a straight student, but what about collecting all the information that should be for that student? Brandon?
You need to make a dictionary to pass to create an actual student instance, and then you need to pass that into add a student. So you do create a student dictionary.
All right, so let's say student dict
So you need their first name, last name. We can auto assign them an ID if we had like an ID counter, or you can I just arbitrarily gave them an ID when I made mine.
All right. And first name, last name, what's the other stuff? Age.
And grades. Yeah.
All right, so you're saying to give it one automatically, so I know this is going to be a string method of the max of integer x for x in oh man, what is this thing called? This is CLS dot students dot keys. For x and CLS, students dot keys. Right, why are you crying? Max, that should return 1. Oh, that's why you're crying. All right, and we want to add 1 into that, right? That was
Yes.
aggregating. All right. So there's one thing. How do you want to handle the first thing?
I guess you collect inputs for every single thing.
All right then. Then in that case, let me go ahead and copy that. All right, and in this case, it would be first name. You're crying because I forgot a comma. Into your last name. Comma, enter your age. And enter your grade. All right, so there you go. We have our ID, our first name, last name, age. We should handle for improper input, but in the interest of time, we'll leave it this way for now. So now I could build my student dictionary. Now, what do I need to do next?
You can either return the student dictionary, but since add a student requires an instance, you should create an instance with students of the dictionary.
Okay, so I will return the instance of a student with the student dictionary. All right, awesome. There you go. So now we created 2 methods. Let's do a quick summary here. We know that we need a method for adding a student to the database, which was pretty straightforward. We grabbed the class level attribute students, set an ID as the key, and then set the student as the value. Then we leave a success message for a return of said student has been added to DB. But in order for that to work, we needed a class instance of a student. So we created a method named create student instance, which grabs a student dictionary with an automatically assigned ID. This then takes in the input of a first name, input of a last name, age, and grade to build our dictionary. And then we return that class instance. Right, let's open it up for some questions, starting off for Chris.
Yes, for line 34, is that saying like every time it goes, so if it goes to whatever's the first on the list and the second, it was assigned ID 1 and 2? Or what does that print out for ID?
Yeah. So here I'm using list comprehension. I am creating a list of IDs that are integers because currently they are strings. I have to turn them into integers because I'm utilizing the max function. What I'm trying to do is grab the highest number currently located within my ID, within my database. As we know, students could be deleted and added. So if a student is deleted from the middle, I need to make sure that I account for that and that my numbers continue on increasing. If I just take the length of the list and add one, then I could have repetitive numbers as my ID, which is not what I want. Right? So instead I grab the max value of that, add one to it to ensure that I'm always increasing up by one ID. And then I'm creating the rest of my dictionary. Does that answer your question, Chris?
Yes. And then you made it as a class method. I'm still a little confused with class methods. So I'm trying to see why would you, yeah, right, yeah, 31.
So I created it as a class method, and the easiest way to think about it is think about it kind of like a, yeah, I think people is a good way of looking at it, right? If we have a student themselves shouldn't be able to create another student, right?
Right.
Belong to something above a student, and that something above the student is the class.
Yeah, okay. Gotcha.
Thank you.
Gotcha.
All right. All right, Eric.
I was curious if it would make sense to call the add a student class method in the init method for the student, just to avoid additional function calls once you, like every time you make a student. So I know there it is for load data, but if you're gonna create another student instance, not with the CSV,
Mhm.
would it make sense to right there in the init method, if you were to call the add student function to make sure they were in the dictionary of students? I don't know if that makes sense the way I asked that.
I'm not able to understand it, your question. I apologize.
So we just defined, if you scroll back down to add a student.
Yeah.
And we pass in student there, to define, essentially we're gonna run that every time we add a student, right?
Right.
So in order to like eliminate running the add a student function every time we add a student, at least manually by calling that method, would it make sense to just append down there add a student and it would take self?
Just like that?
Yes.
Yes, that
I'm
could.
tracking it. I'm tracking it works the way you defined it. It seems like that would be more efficient to do.
Yeah, this could definitely work. And that would definitely help us out. Yeah. That way we don't have to do this part.
If this was going to, like, you were pushing this code out, you'd probably want to put logic in there in case you were taking in from a CVS file, would you not? Like, I mean, I'm just wondering. This is where I don't know, because the load, like when we load, we pull everything in, but then there we're calling it. So would that cause errors if you added that call at the very end of the init file? Or would you need to put logic above it for like a check to make sure you're not bulk loading? I've always wondered this myself, so thanks for asking, Eric.
This is a great question. Let's actually try it out, right? So there we can have our CLS classes. We have our methods. We know what each one of our methods is doing. So let's run this quick data here. Just from this specific function of students load data, we know that it's already going to take in a dictionary. And every time that a instance is made, our add student should be triggered. So we should still see the same output of, at the very end, seeing a dictionary with keys and values. So now when I run it, we can see that it worked correctly, right? We have an empty dictionary to start off. We then load all of our data. In our load data function, we're not manually putting it into our dictionary. Instead, we have it within our init method, where it's calling in self. And that's how it's getting added into our dictionary. That was a good catch, Eric. Thank you. All right, Brandon.
Is it preferable to store the ID as a string in the students, or can we cast it to an integer? Because I feel like we could avoid some logic here and create a student instance whenever you load a student.
Yeah, definitely could have had it as an ID, or could put some logic in here to turn that first thing into an ID, right? I could say row ID is equal to integer row ID. All right, and that would improve it. That way I already have integers. And now instead of casting this or doing list comprehension, I could just go ahead and say max of cls.students.keys plus 1.
It just shortens it a little. You have to not convert it back to a string as well.
Oh, thank you. Almost missed that. There you go. And now we have integers rather than strings as our keys. All right. Chris?
Yes. Can you scroll up just a tad? See all the class methods, I guess.
Yeah.
So for class methods, so when load data is activated, so it automatically does this because it just loads in, and then it goes to add a student to the dictionary.
So we call the load data method down below, which starts reading through the CSV file, right? What calls the add student method is at the very end here, we're creating an instance of a student. When we create the instance of a student, we have it as part of our init up above to add the student into the dictionary up above. So we're eliminating an extra step.
Okay. So, but yeah, you have add student self. Where does students? Oh, in the method add student, there's, yeah, okay. I never seen it used like that. I only see it as like a variable for the init, not as call methods inside the. That makes sense. What I'm saying?
It does, yeah, it definitely does. Let's try to create a student now, and I apologize, Milo. I'll have to get back to your question here shortly. And let's go ahead and print a students one more time. All right, so now I have my terminal program. Let's go ahead and run this a little bit. So it says, please enter your first name. I'm going to put in there Francisco. Last name is Avila. Age is 13 this time. And enter my grade, Fat OF. All right, and now we can see that a new student was added. We now have Francisco registered as a student instance. So that was quite a bit of code, and we've done a lot just to be able to add a student, all right? Now let me go ahead and take this copy and grab it from the curriculum. So I'm gonna make a new file here. Name that one studentscompleted.py. And that's where I'm gonna run the code from our curriculum. So here we have a whole menu that will allow us to view students, add a student, delete a student, and even exit our practice. It has a writing method to be able to overwrite the current file that we have, right? And rather than student data, this should be students.csv, right? It has a method to overwrite the file that we have so that we can have data being triggered into it, and a bunch of logic for being able to create a new student. It looks a little bit different than what we have and has a little bit of different conventions, but this should look pretty familiar to what we've done and should be easily readable for us. So now I'm going to go ahead and run my terminal program so that we can see this final product. So there you go. Hey, what do I want to do? I want to view student information. All right. If I want to view student information, it lists out to me all of the students and it shows me all of their information. Okay, great. I want to add a student. Well, this one gives me an opportunity to have a student ID being entered. To age, right? And if I view my students, we can see that it's all in there as well. All right, but now let's take a look at the students.csv. Francisco has now been added because we have a writing method to be able to add that information. So now if I want to delete a student, I have to enter my information again. All right, the student was deleted. Let's take a look at our CSV file. All right, Francisco's now gone, so it's working correctly. And then finally, I can go ahead and exit. Now, this is very simple CRUD application that we just created, right? I'm able to create, read, and we're not able to update, but I am able to delete a student. But look at all the lines of code I had to write just to make that happen, to include the class. It's quite a bit complicated and definitely not worth the squeeze. So there's got to be a better way to manage all of this data. All right. And the better way to manage all of this data is going to be through PostgreSQL. So the entire purpose of this first portion of the class is to show us how inefficiently we could work without having database management systems being included into our applications. Does anyone have any questions over anything that we've covered up to this point? Go ahead, Chris.
So I'm just trying to realize or figure out once you save something to a dictionary and once you load something from the CSV file, they both talk to each other when you can update into the dictionary will also reflect in the file as well?
Right.
Or
So just like I can read from a file utilizing the mode R, right? That means I'm reading from a file. I can
Mhm.
write into the file.
oh, so that's where it's at. So it's not writing into the dictionary. So the dictionary is just reflecting what's in the file.
Right. So originally I grabbed all my data from the file. Once I make a change to the data, I can update the file with this writing student data method.
Got you. Okay. Thank you.
Awesome. All right, everyone. So that's going to take us to our halfway point here. We're going to break for 30 minutes. In that 30 minutes, I would like to ask everybody to read the two reading assignments that there are for this break. So currently right now it is 10:55. We're going to reconvene at 11:25. Thank you so much, everyone. Enjoy your break. All right, everyone. Right before we left, we talked about how we could handle data inside of a CSV file and the considerable amount of code that we have to write to just manage this data. Now, if we take a closer look at our students completed.py file, one, it doesn't really look much like what we created, right? Ours is a little bit more stricter and more it's more isolated. Behavior is more isolated so that everything can work as expected. As previously mentioned at the very beginning when we first created this class, right, we would also want some getters and setters to make sure that information is going in there correctly and only if it's the correct data type. And there's a little bit of more validation that we would need to include for our students, right? When I add a student, I should probably check that that ID doesn't exist in that file. And if it does, then this should throw some sort of error. We don't have the ability to accept improper input when we add a new student. So that also needs to get fixed. But that's all a lot of considerable logic and code that we would have to add into our scripts. Now, there's got to be a better way to handle this. That's where relational database management systems come in, and specifically PostgreSQL. Now, something that I really like to do is, as we'll see later on, once we go into our Django frameworks or we start talking about building our servers, most of our classes or our database tables will be represented in Python by classes. So something I really like to do is have the class pulled up to my left-hand side so I can see all the attributes. And then I like to create my table in this tool called drawSql. And I'm going to share that here on X-ray questions so that everybody can also use it if they would like to. Now, this tool is really cool in the fact that it allows me to create a table and I could visualize it. It may not be that much of a difference as of now, but later on when we have multiple tables and they have to relate to one another and talk to one another depending on specific attributes, this tool definitely helps, especially for visual learners. So I'm going to go ahead and start here. I'm going to create a new table. So this table is going to be named students, just like before. And you can see that it already has an ID, but it's also specifying, hey, what is this, right? This is going to be an integer ID. I could change that to a couple of other things, which we'll go into as we start diving into SQL. So now let's add the remainder of our columns. So here we have a first name. And we could make that a line string for now, just so that we could visualize it, but we'll go into what it will be represented as in PostgreSQL. All right, so we have our last name, which is a line string. Now we need an age, which is going to be an integer type. And then we need a grade, which will also be a line string for now. All right, so that's a lot simpler. It's also a lot easier to write as far as creating the actual table and being able to visualize it, getting a little bit of typecasting already built in there. But as of now, we haven't really discussed what is it that this drawing does for me, right? Why am I creating all of this? Well, I'm going to do the same exact behavior that we created with Python within SQL, right? I want to be able to create, read, update, and delete information from a data table inside of SQL. So let's get a little bit of an introduction into SQL commands. So currently I have my terminal here. I'm going to go ahead and write PSQL. For some of you, that might knock you straight into SQL. For me, it does not. I have to type in PSQL Postgres. And now everybody should see the same thing, right? We should all be within Postgres, and we know we're within our database management system because of this equal sign, pound sign. This is showing me, hey, you are now in SQL. Well, we've been talking about relational database management a lot now. The next thing that we're going to be talking about is how to create insertions or even create tables. So let's go into some commands here, some basic commands. The first things that I want to cover is how do I see my list of commands? Is if I do \L, excuse me, not my list of commands, my list of databases. If I do \L, you'll see that it populates a list of databases. These are all different databases that I have for different applications that I might have created. I should probably clean up my database, my PostgreSQL, because as you can see, I have a considerable amount. Some of them are repetitive, so they're more than likely used for some demoing. But there you go. Right, these are all of my different databases. When you guys run \L, I believe the only one that you'll see is Postgres. All right. Well, let's say that I wanted to create a database. Like I said, I want to handle my students. So I could say create, and typically you want to type things in SQL that are commands in capital letters. So I'm going to do create database. That's in all lowercase letters. And what I want to create now is the name is going to be students. And we can name this school if we wanted to. Let's do school just so that we have that. And I'm going to prepend that with DB. Now, when it comes to naming conventions for databases, I would try to stick to lowercase letters. Don't use capital letters. It turns really tricky for PostgreSQL to be able to find the correct database if you start using capital letters. And I would also try to avoid numbers. So please stick to actual characters, all lowercase. And if there's any spacing, utilize snake casing to symbolize spacing. All right. So now you can see that I'm ending my command here with a semicolon for creating my database. And I'll get a nice little message saying, hey, there was a database created. Cool. There's a couple of other ways for creating a database. This is only an introductory day. We'll go in more detail as to all of the different commands that there is for SQL later on in our SQL week, where we'll go into SQL for a total of 3 days. But for now, we can see that I have a school DB. If I run \L and I scroll down, I can see here, school DB has been created and it exists within PostgreSQL. Fantastic. Well, how do I connect to that database? How do I get there? Well, the next command that I'm going to utilize is \C. And then from there, I'm going to specify I want to use school DB. Well, we can see that originally I had Postgres on the left-hand side, and now I have school DB on the left-hand side. And it's telling me, hey, you are now connected to database School DB. As user, Francisco Avila. All right, let's do a little bit of review here over what we've done so far. All right, so inside of this README, I'm gonna go ahead and type in most of our commands that we've utilized. Again, the command PSQL, followed by the database name. We'll enter PostgreSQL. \L will list all databases within Postgres. And \C, followed by the database name, will connect you to a separate database. I always misspell separate. There you go. All right. At this point, does anyone have any questions over anything that we've done so far? Okay, great. So currently we're within SQL and within my school DB. But how do I store all the CSV data inside of that school DB? And why did I make this table? Well, I'm going to create a file here named students.sql. That's going to stand for SQL Queries. That's where I'm going to turn this drawing on the right-hand side, or this table on the right-hand side, into an actual SQL command, right? So what I want to do is I don't want to initialize a class like I did in Python. Instead, I want to create a database table named students. Inside of this database table, I know that I want an ID, which is going to be a serialized primary key. Now, serialized primary key, what does that mean? Well, just like in students.py, when we create a student, we did this max function here to ensure that each entry was escalating one step. Well, that's the same thing we're going to do by turning it into a serial primary key. The next thing we're going to cover is going to be our first name. This is actually going to be a varchar. Now here I have it as a line string. A line string and a varchar, including text, can accept characters and numbers. Now the difference is how much space or memory space is allocated for each one. Now a varchar, I can specifically tell it, hey, I only want you to utilize 50 characters. Right? And what it looks like in memory space is it's not occupying all 50 digits. If there's only 25 characters being entered, then it will only dedicate space for 25 characters. Whereas if I utilize something like char or line string and I specify a length, even if that length is empty, it will still use the leftover space. All right, so now I have my varchar. Now I'm going to move on to my last name, which is again going to be a varchar. My age, which as we said, that's going to be an integer. And then my grade, which is going to be a character of 1. Now, before we utilize varchar, now I'm utilizing character. Well, that's because I know that the only grade that I'm going to accept is A, B, C, D, and F. I'm not accepting plus or minuses. Just one specific character is being entered as the grade. All right, so first, I created a student class. That student class then turned into a table on my right-hand side, which I then turned into a SQL table inside of my SQL file. does anyone have any questions regarding how I came about creating this SQL table? Go ahead, Chris.
First name and last name, is that the max characters it can be put in first name or last name?
That's correct. That would get cut off at 50.
Gotcha. Is
All right.
this now?
Oh, go
sorry.
ahead, Chris.
Oh, sorry. Is this now talking to your drawSql website or no?
No, these two aren't communicating at all. All this is for a visual aid for me.
Oh, okay, got you.
All right. So now that we have this information, I've been able to create a table. But currently inside of SQL, if I want to take a look at whatever relationships are inside of it, I can run \d. And I can see that there's no relations. There's no database. There's no data table saved inside of this database. All right, so let's add that into our README here. Let's run \d shows existing tables within the DB. All right. There's no relations here. So how do I actually run this into SchoolDB? Well, I can utilize pSQL to do that from my terminal. There's two ways of doing it here. I see the one in the curriculum actually utilizes the one inside of SQL. So let's do that. All right, I'm going to run \I and then try to execute students.sql. All right. So now you can see I did \I students.sql and I get back a create table message. All right. Well, now what happens if I run \D? Well, now in \D, two tables have been created. I have a students table and I have a students ID sequence. Now this secondary table here was created automatically. And it was created to keep track of the sequence of each individual entry into the database. So this is what's keeping track of my incrementing ID. And that's just keeping track of my actual data. Well, how can I take a look inside of both of these, right? Well, what I'm going to do is I'm going to run a select query. Now a select query looks as such. Select, I'm going to grab all attributes from students. And place a semicolon. Every time I finish a SQL command, it will always end with a semicolon. Now let's run this. All right. Well, there you go. We have my ID. We have a first name, a last name, age, and grade. It's my entire class being placed into my SQL table. Great. Well, now what happens if I want to see from students ID sequence? Well, in students ID sequence, we have the last value that was called, which is 1. We have a log count, so a count of how many times this has been called, which is 0. I don't have any entries. And then I have an is called. Okay, it's true. I don't have any entries of this information, right? It's false. It hasn't been called yet. All right. Awesome. I started off with my class. For my class, created a table, which is in SQL, specifying the types that it should accept. So now I don't have to worry about casting information. And the validation process will be taken care of by SQL itself. Then I loaded this SQL script into SQL utilizing the \I command. So let's run those two commands here. \I, name of script. I know that's misspelled, I'll fix it. We'll run a SQL script within a DB. And then I have my select all from table grabs all attributes from a data table. All right. Let's open up the floor for some questions here. Go ahead, Joseph.
So what's the benefit of doing it the way you did, creating that table using the students.sql file and then loading it using the \I command versus just using the terminal to create the table?
Yeah, that's a great question. So to everybody who didn't understand that question, all he's asking, well, this create table script that I wrote here, what's necessarily the difference between writing it in a script and just putting this command straight into my terminal, right? Like, why do I need a script? Now, the answer is you don't necessarily need a script. You're right. I could just copy this and paste it straight into my terminal and execute it as normal. Now, the reason why we write SQL scripts is to have a living record of all of the different queries or commands that were ran against a database so that we can go back if anything goes wrong within the database or within some of our information in there. We can go back, see what commands were run, and then analyze where that error came from and how we can fix it. Does that answer your question, Joseph?
Yes, thank you.
Of course. Any other questions? All right. Doesn't seem like there are any other questions. So let's continue on with our SQL query now. So now we have a create table information. And we were able to select all from both of them to grab a little bit of info. But as of right now, it's empty. We haven't touched our CSV file at all just yet. So how could I do that? All right. How do I specify which CSV file is it that I want to grab? Well, there's a couple of different ways. The most popular one that I've seen students use is they right-click here. And after right-clicking, they say copy path. So I'm copying my absolute path to this file. Now, you need your absolute path to the file because PostgreSQL doesn't necessarily live inside of some directory of your project, right? It lives on your machine, but it lives, how do I call it? Linear to your machine. It doesn't live within it, right? It's ran as a background service, meaning that whatever you're doing in your operating system is running next to it. They're not related to one another. So you need to copy the absolute path so that you can specifically tell it how to find this file. So I'm gonna copy my command here. So what I want to copy is students, which is what I believe I named my table, was students. And I want to copy it from, and now in single quotes, because that's the only thing that SQL will accept is single quotes, not double quotes, I'm going to paste that absolute path. And then I'm going to say, hey, this is a CSV file. So they need to know a delimiter and if there's headers included or not. So the delimiter, which is what separates each entry, is a comma, and CSV headers are included. All right. So again, I'm copying students from this CSV file where the following delimiter is a comma. If I take a look here, we see commas are separating each entry, or excuse me, each data entry of each entry, right? And there is a CSV header included. So now when I run this command, you can see that 5 students were copied. Well, let's run my select query now. Select all from students. Now, when we select all from students, we can see that all 5 students appear within my data table. Excuse me. Now that all 5 students are within my data table, my data is easily managed, and I could start running some of my CRUD application into my database. But before we go into more complicated SQL queries, let's go ahead and give it a time so that we can take a look at some questions. I saw a hand up from Mikhail.
Oh, you already answered my question.
Okay, perfect. Daniel?
I'm not sure if I'm getting ahead of myself, but is there a way you can automatically update from the CSV file instead of manually going from copy to student CSV to student SQL?
Copy to, sorry.
Like, is there a way to automatically update the table instead of copying the CSV file from the CSV to the SQL?
Yeah, so that's where the SQL file comes in, right? If you're saying to automatically, like as soon as the table is created, it reads the CSV file and copies information, no, they have to be separate commands, right? You could put it all within one command, utilizing like some separator, but it's still executing multiple commands in one line. All right. So instead, what you can utilize is just continue utilizing the SQL script, and you could copy and paste this information here. So now you can see that a create table has been passed, and then the copy command gets access right afterwards. So this way, when you execute the SQL query, it will create the table and immediately copy the students. Does that answer your question, Daniel?
It does, thank you.
Gary?
What does the delimiter do again?
I'm sorry, could you say that one more time?
What does the delimiter do again?
Yeah, so delimiter stands for these commas. We're telling it, hey, how is this data separated? I understand this is a CSV file, but is it separated by commas? Is it separated by backslashes? Typically, it's always going to be commas, but when it comes to SQL, we need to explicitly tell it the delimiter type. Does that answer your question, Gary?
Yes, thank you.
Of course. All right. So now that we have this information, we've looked at a couple of different ways to work with data. Let's go ahead and move into some select queries to grab data and manipulate our information. So just like before, if I wanted to list all of the students, that seems pretty simple, right? I could just do a for loop and list all of my students. And we even went into creating a representation method. So what does SQL have to offer that Python didn't already bring to the table? Well, in SQL, we can run queries such as select, and I can specify the attributes like first name and last name from students. And now I can still run \i students.sql. And now we can see a table gets formulated. A table with first name and last name, and it has all of their values separated for us. I can run conditional statements rather than having a for loop where I'm saying, hey, where only if they have a letter grade of A, I can say where grade is equal to A. Oh. I can also change the attributes that I'm grabbing. Maybe I don't want first name and last name. Maybe I want everything. And now you can see that it's selecting from students and running conditional statements to grab the specific number of students that I need. Does anyone have any questions up to this point? All right, if there aren't any questions, we're gonna get into a little bit more complicated queries now. Let's say we want to grab the grade and the count of all students who were able to achieve a specific grade, right? Well, I can do that. And actually, I'm gonna leave that there, comment it out, by saying I want to select the grade and the count of students who achieved this grade as student count. And I want to do that from the data table named students. Now I'm counting and I want to make sure that I'm grabbing information where grade is isolated. But as we saw before, grade comes in as various different numbers of times. So I need to isolate those, right? Especially if I'm counting them. Well, in order to isolate them, I can utilize the group by function. So I want to group by grade. So now it's going to group the letter A's all together, return 2, the letter B's together, and the letter C's together. So now when I execute my script again, I get letters B, C, and A with 2, 1, and 2. Any questions regarding this query? Chris?
What will be the code to put it in order where A is first and B is second and C is last?
Yeah, that's a great question. And let's see. Hopefully my SQL skills are not too shabby. I have to figure out what the correct command is, but I'm pretty sure it's something along the lines of sort by something, and then you just specify grade afterwards. I apologize.
I think it's order by.
There you go. That might be it. Yeah. There it is. Thank you. Appreciate it. And then if you want it in reverse, you could just pass in the descending argument. And then that puts it in reverse. All right. Any other questions? Okay, good. So this should be pretty hopefully easy for us to read. So with that said, how could I grab all information from students where they have an age between 18 and 19 years old? Can anybody walk me through creating through that query? Let's hear it, Daniel.
So we could probably do, so we're trying to select the ages 18 through 19, right? So it'd be select, would it be the age? Select age from students.
Well, we want everything from the
Oh,
students who are between 18 and 19.
okay, so then we use that at the star sign from students. And then we would be do where age is equal to 18. And is
Okay.
there a way we could separate that for so where age is equal to 18 and 19? Or do we, oh, we have to do the,
Yeah, so you could do it this way. All right.
okay. And
that's
then we,
good.
oh, and then you do we need to order it or are we just trying to get the count for all the ages?
No, this is good. We just want the information, right? So let's go ahead and run that. And it's giving me none. I think what I want is or, not and. There you go. So now we can see all of these. That's one way of doing it. Can anybody think of a different way? Go ahead, Erica.
I was wondering if you could do the select from students where age is over equal 18 and ages under or equal 19?
Yeah, we definitely can. The cool thing about SQL is that we could also pass in a between argument. And we-
Oh,
18 and 19. Nice. Both of the ways that you just mentioned also work. Brandon? If you're speaking, you're muted.
And is inclusive in SQL?
Inclusive in SQL? No,
Yeah, or
the
sorry,
operator-
between would be,
Yeah, the operators still work the same. So
okay.
We still get the same circle here, right? Where and is only when both conditions are met, and or is when either of the conditions are met. All right. Okay, awesome. Well, what if I only wanted to see, what if I only wanted to see the 3 students in class, the top 3 students in class, right? And I wanted to order it in some form of alphabetical order. How could I do that? Go for Brandon.
Let's try select all from students where grade so what I want to say is select all from students where grade is the highest, and only the top 3, and then sorted by name, first name.
All right, so where grade is one of the highest. All right, so let's say, I wonder if we could order by multiple things, right? So let me try to format this a little better. That may help us visualize it here. So let's do an order by grade, since we know that's alphabetical. Let's see if those both order bys work here. So it looks like we have a syntax error. Maybe we can do and. Nope, definitely not gonna work that way. All right.
Do we
so
need a,
go ahead.
will we need a comma?
No, it doesn't
Okay.
work. Yeah. Where grade is greater than C. Let's run that. All right, so it's giving me issues here, and that's coming from this grade greater than C. It doesn't really like the comparison of letters because it turns them into a numerical number in the background. So if we take it one step at a time and we do order by grade and limit 3, we should see our top 3 there, A, and A with B, and then we would have to add another order by statement, which I'm pretty sure. Oh, go ahead, Brandon.
Adam Weiss said to put a comma, so grade, comma, first name.
Got it. So that it would be able to do both of them. And I think that's what you were trying to tell me as well, right?
Right, yeah.
Okay, got it. All right, and there we go. Now we have our select statement where we ordered information and we limited by 3. All right, rather than writing a whole Python algorithm with a couple of if and else statements and a couple of dunder methods and classes, all we really needed was a create table statement, a copy statement to grab everything from our CSV data. And then after that, were able to start writing queries to grab information out of our database. All right. Any questions up to this point, Chris?
Yes. How did you find the pathway or the copy from how did you find that pathway?
Yes, there's two ways of doing it. I could run pwd on my terminal. That shows me my working directory. So I can
Gotcha.
grab the pathway and then include the CSV file. Or you could hover over the CS or the file that you want, right click and copy path.
Oh.
That will do it for you as well.
And at the end, it has to specify the CSV header and delimiter.
Yes, that's correct.
Okay. Gotcha. Thank you.
Of course. All right. Any other questions? Go for it, Polly.
What if you had two CSV paths, kind of like what we did for the assessment? How would you write that?
Well, they would go into two separate data tables, right? So we have enough time. Let's go ahead and answer that question real quick. So if I were to do something along the lines of what we had in our assessment, this would be I think it's a client. No, it's customer. There you go. This would be customers. And this right here would be videos. And the CSV paths would also show stuff, where this would be customers. And this would be videos. Right? And they would have their own tables to fall into. Does that answer your question, Polly?
Yeah, I was just confused. I thought it was like a way to like put them together, but yeah, I guess. Got it.
Awesome. All right. So finally, let's go ahead and run into some insert queries, right? How would that work? What if I wanted to insert data myself? Well, currently right now, if I try to execute this script with this create table, it's going to give me an error. It's going to say, hey, this relationship to students already exists. So I already have this table, all right? While I'm experimenting, I'm learning how to utilize SQL, or I'm setting up my database. So it's important that I'm able to manipulate information and drop database and recreate them as I want. So I'm going to add this command saying drop table if exists students. So that's going to drop the table students if it already exists. It will then create my table. And rather than copying students, I want to insert student data. And I'm going to do so as such. I want to insert into students the values first name, last name, age, and grade. Notice that I'm not including the ID, and that's because that's going to be automatically generated for me. So those are the fields that I'm going to be entering information to with the following values. So the values that I'll be utilizing are John. I guess it really doesn't matter if I have good spelling or not. Doe, I'm gonna pass in 18. Let me just demonstrate this. What happens if I pass in a string, right? I'm gonna run this script real quick, just so that we can see the errors being risen. Insert into students. Let's see. So here we see our drop table command happening, but it doesn't seem like our create table command happened. And that is because I was missing a semicolon. There you go. So now we dropped the table. It then created a table. for students. But now we get an error. It's saying, hey, the value is too long for character of 1. So that's happening here. All right, let me change that into an A. Now let me run it. All right, so the insertion went through. It happened with 1. So let's go ahead and run a select for you. Let's say select all from students. Well, now we can see 1, John Doe, 18, and A. Now, John Doe never had an ID that was automatically generated. And this 18 was a string, but inside of my actual database, it's getting saved as an integer because I specified that it was an integer. So she actually made the database actually made a change of typecasting from string to integer. All right. So now what if I had multiple values, right? The next one's going to be Jane Smith with age of 19 and a value of B. Well, notice that I added a comma rather than a semicolon to signify, hey, this is the end of the first entry. This is a secondary entry. Well, now when I run my script, looks like we get an error around
The double quotes.
Give me a second. Oh, that's what it is. Thank you so much. And I specifically said it to everybody that doesn't accept double quotes. There you go. Now let's run it. All right, so there you go. We get our data table. Everything's working correctly. Now let's run my select all from Jane. Oh, excuse me, from students. Now we see 2 entries, each one with their individual data and their automatically generated IDs. And that is it as far as our introduction to SQL for today. At this point, does anyone have any questions over any of the topics that we covered today? Erica?
What if one of the values is none?
What if one of the values is null?
Yeah.
Well, we didn't say that any of it was nullable. So if I try to add null and I try to execute my script, so we can see that it goes in through. And if I run my select query, we can see it shows up as nothing. So if you wanted it to not make it available to be null, I believe you could do, is it not null? I have to refresh myself in SQL, but I believe it's I know there's a specific way to tell it, hey, this is not nullable, so don't do that. Does that answer your question, Erica?
Yeah, but it gives you a small follow-up. So if, for example, you want it, because it automatically turns into a lot of like into like an int and everything. If you wanted to specify that you want null characters that or nulls to become something specific, like let's say a 0, would you be able to, or would you have to like afterwards work on the data?
You would have to do that afterwards. You wouldn't be able to do it prior to. That's actually something that Python would come really in handy to fix for you.
Oh, perfect. Thank you.
All right. And I think I saw another hand being risen.
That was me. So far I feel like the database is making a lot of things more simpler for the Python side. But if we were to delete John, would Jane just take his spot, or is that a command that we have to put in?
Or to delete John, would Jane just take the spot?
Yeah, since like the comma annotates the first entry and then Jane's the semicolon, would Jane become first ID? Let's say we delete him from the database.
Mm-hmm.
And then she would be the first entry.
I think we would need to delete after the insert statement to answer his question.
I see what you're asking now. So you're saying what would happen if I delete him there? Right?
Yeah.
Okay, well, this would still be maintained as 2/Jane Smith it wouldn't get reset. Let me see if I remember how to delete. All right. And there you go. You still have Jane Smith with 19. And if I were to insert someone else or insert another student now, let's say that I inserted John again. Hello. I forgot to run my /i. Students.csv. Oh. All right, and now if I run my select query, we can see John is now inserted again, but now he has the ID of 3 instead of 1.
Okay, thank you.
Of course. All right, any other questions? Erica?
No, sorry, I pressed by mistake.
Okay. All right, if there are no questions, that's going to conclude our introduction to PostgreSQL. Again, this is just an introduction. We're going to be going into it in depth in the coming weeks. So I hope that's a good intro to get us up to our full stack application at the end of this module this week.
I actually do have a question.
Go ahead, Brandon.
So can we look at the copy students from blah, blah, blah? So I noticed that when I try to break it apart on line 15, when I try to break it apart into chunks for note-taking purposes, I can't put the commands on separate lines. So for example, if I create a new line after the from statement, is there a way to do that to where each thing's on a separate line without breaking it?
Yeah, so you could tab it in, I believe.
Okay.
Let me try it out just to make sure that is correct.
It did not work for me.
Let me try. Yeah, it doesn't seem like it likes that for copy statements. Yeah, I'll have to figure out if there's a way to chunk that up. Most SQL queries, it will let you actually indent under it.
Okay.
But it might be something to do with the pathing that breaks it.
Okay, no worries. I'll look into it some more and I'll get back to you if I find anything.
Syntax 0 from, yeah. All right. Thank you so much, everyone. I'm going to go ahead and stop the share and stop the recording, and then we'll be good for lunch.